Let's take a look at page 276, example 10.13 in this not so fancy video. What we have here is a circle. We have an arc here of a 0.6 radians, not degrees, radians, and we're asked to find the minor arc AB. So we're trying to find this length from here to here. We have a formula here, arc is equals to r theta. Arc length is also considered L. You have a formula for this. L is equals to r theta. And the radius is given as 5 centimeters. So we have 5, and theta is given as 0.6 radians. It's very important that we make sure that we use radians, not degrees. Otherwise, you'll have the incorrect answer. 5 times 0.6 is 3 centimeters. B. Now, what if we're given the same problem, but instead we're asked to find the arc length of the giant outer partial circumference from here all the way around to here, not including this part here? Well, to do this, we could use the same formula. We have the radius being 5, and we could use the angle, which is the entire rotation minus this angle here. The entire one full rotation in a circle is 2 pi radians. 2 pi radians minus 0.6 radians is the leftover angle here, theta. Theta is equals to 2 pi minus 0.6, which is about 5.683. And then we use our arc length formula again. This outer arc here, the major arc, is equals to r theta, which is the radius is 5, and the theta we just figured out, multiplied out 3 sig figs, we have 28.4 centimeters. Okay, now let's take a look at page 276, example 10.14. We have another circle here, and we have this nice shaded region. The question A is find r, the radius. So radius r is what we're trying to find, and what we have is we have arc AB. This is just practicing the English vocabulary. Arc AB subtends an angle of 52 degrees. So when you read this fancy English, it means that this arc corresponds to 52 degrees. So to find r, we simply use the formula. Arc is equals to r theta, and what we have here is just rearranging. You divide both sides by theta to isolate for r. We know what arc is. Arc is given as 10.9 here. And theta, just be careful that we convert first to radians. So we're given 52 degrees. Just make sure that you remember that this formula works with radians. And so we convert degrees to radians by multiplying by this fraction here. Notice how the degrees cancel out, and we get 0.908 radians. So we have theta here converted to radians, and when we divide 10.9 divided by 0.908, we have radius is about 12.0 centimeters. What's the perimeter of the shaded region? The perimeter is like an ant walking around the outside, traveling this path here. The perimeter is going to be 2 radiuses, 1 radius plus the arc. And good thing the arc is given, because this is a curved shape, which is a bit difficult to find. But what we have is we have 10.9 here as the arc, and we have 2 times the radius, which we previously figured out was 12.0. And using our calculator, the total is 34.9 centimeters. Okay, so now let's take a look at page 280. We have a nice circle here. We're given this fancy notation. This little house type caret symbol means angle. We have angle A0B. This angle here, the angle is in the middle, is 1.2 radians. If there's no unit specified, it's radians, not degrees. Find the area of minor sector AOB. The area is referring to this shaded region here. The word minor means the fact that this area is pretty small, smaller than half. The major area would be this leftover here. So it's good to memorize this formula. We have area of a sector is 1/2 theta r squared, or r squared theta, same thing. And try to visualize what the word sector means. You can make a story, perhaps the Hunger Games. We have this sector, this very important sector, and this is where there's a great revolt. So we just take this plug and chug type question here. Area is equals to 1/2 theta, which is 1.2 radians, and r squared, which is 6 squared. Use your calculator. It's about 21.6 centimeters squared. We just found the area of a sector. Okay, so let's try page 280. This here is 10.16. A sector of a circle has a perimeter P is equals to 12 centimeters. So this is the sector here. This diagram is not provided, so it's a good idea to draw this picture here. And we know that this plus this plus this is equals to 12. Theta is given as 50 degrees. Our challenge is to find the area of a sector. This here is simply some formula question. Now what are we given here? We're given this theta in degrees, but this sector formula works with radians. So we're going to convert degrees to radians, and so we have the degrees canceling out here, and we get 0.873 radians. It's always a good idea to keep all the digits on your calculator. And so what we have is perimeter is equals to 2r plus the arc, and you can see that very clearly on the picture here. Please recall that arc, there's a formula. Arc is equals to r theta, or theta r. And so we plug this theta into here, and what we get now is 12 is equals to approximately 2r plus 0.873r. Now look at the coefficients of r here. We simply add them, and we get 12 is equals to approximately 2.873r. Divide both sides by the coefficient. R is approximately this business here, which is about 4.177. And now that we know what R is, we can finally answer the actual question. What's the area of the sector? What is this area here, this shaded region? It's 1/2 theta r squared. Theta we figured out was about 0.873, and R we figured out was about 4.177. Using our calculator, we get the final answer. The area of the sector is approximately 7.62 centimeters squared.